Okay, so this one we're going to call the melon problem. So a grocery store purchases melons from two distributors, J and K. Distributor J provides melons from organic farms. The distribution of the diameters of the melons from distributor J is approximately normal with mean 133 millimeters and a standard deviation of 5 millimeters. For a melon selected at random from distributor J, what is the probability the melon will have a diameter greater than 137 millimeters? So this is just like sort of the end of the last one. It's just a normal distribution problem. So what we have, again, it gives us the mean 133 millimeters, a standard deviation of 5 millimeters, and so we can go ahead and draw our normal curve. That's better than the last one, kind of. Mean at 133, standard deviation of 5, and we want greater than 137. So we're finding this area here. So we should expect a probability of less than half, right? We push menu, name of the class you're in, name of the thing you need, type of thing you need, and there we go. We need, crap. Now the reason we can go ahead and assume it's normal is because it says that it follows an approximately normal distribution, which means we can skip the part where we justify. So we can just go straight to the calculation part. So, we go to normal CDF in the calculator. We want a lower bound of 137, an upper bound of infinity. Our mean is 133, and our standard deviation was 5. And there you go. The probability is 2.12. So, using a normal CDF with mean 133 millimeters and a standard deviation of 5 millimeters, the probability that a melon selected from distributor J is greater than 137 millimeters is 0.212. And there you go. That's all there is for that one. All right, so distributor K provides melons from non-organic farms. The probability is 0.8413 that a melon selected at random from distributor K will have a diameter greater than 137 millimeters. For all of the melons at the grocery store, 70% of the melons are from J and 30% are from K. For a melon selected at random, what is the probability that the melon will have a diameter greater than 137? So for this one, it's best if you create a tree diagram because you have branching probabilities. This would be a good place to start. We have melon is drawn from J, and then the probability that it's greater than 137 millimeters versus not, and then distributor K, greater than 137 millimeters versus not. So a nice thing to do, remember with tree diagrams, you have the probabilities and you multiply as you go along the branches. We want the probability that it is from either J and is bigger than 137, or it is from K and is bigger than 137. So what we should do is fill in each of these probabilities. So 70% of them are from J, 30% of them are from K. And then we found out in problem 1 that the probability that something from distributor melon from distributor J is greater than 0.7 would be, is greater than 137 millimeters would be 0.212, which means the probability that it's not is 1 minus 0.212, which is 0.798. And then if it comes from distributor K, we know it has a probability of 0.841 of being larger than 107 millimeters, which means the probability that it's not is 0.159, because it's just 1 minus that probability. So we're interested specifically in these two numbers multiplied together, added to these two numbers multiplied together. So we can do that real quick. So those two numbers added together 0.4007 is going to be our result. And we would probably draw our tree diagram on this, but since I don't have a way to show you that, I'm just going to assume you use the tree diagram that I made. So the probability that a melon is from J and greater than 137 millimeters plus the probability that a melon is from K and is greater than 137 millimeters is 0.400, what was it, 7? Yeah, 7. And there you go. That's all for part B. All right, now given that a melon is selected at random from the grocery store has a diameter of 137 millimeters, what is the probability that the melon will be from distributor J? Very probability heavy problem here. All right, so this is a conditional probability. So we have to remember the rules for conditional probability. Now remember, the rule for conditional probability is the given scenario, right? So the probability that we have J given G is equal to the probability that we have J and G divided by the probability of G. So all we have to do is figure out what these numbers are. So this is easy. Probability of J and G, we just figured that out a second ago. That's 0.7 times 0.212. That's 0.148. And then below it, the probability of G, that's what we had in the last problem. That's 0.4, around 0.4. So it's just 0.148 divided by 0.4. And there you go, 0.37. 0.37. The probability that a melon will be from distributor J, given that it is greater than 137 millimeters, is 0.37. And there you go. That's it. That's the end. Quick little caveat here. It couldn't hurt on part B to extend this answer a bit, so I'm going to. Probability that then 137 millimeters is 0.4. There you go. Can't hurt.